Lesson on scientific notation. Let's start with reviewing the metric system. The metric system is an excellent example of exponents, but also it's very convenient for us to use because everything is base 10 and we can convert from one unit to another very easily. Now, when I say units, I'm talking about the basic units that we use for measuring volume, mass, or distance. So we would have liters for volume, meters for distance, and grams for mass. Okay, so the prefixes that we have before each of these will indicate whether we have a very large number or a very small number. So kilo, hecto, deca, this is our base unit, deci, centi, and milli. One memory trick that I like to use for this is the acronym King Henry died, unfortunately, drinking chocolate milk. This just helps me remember each of the first letters of the prefixes when I'm doing metric to metric conversions. Okay, so first, if I'm going from a value that is large, like a kilogram, and I want to make it into milligram, I am going to be multiplying by 10 each time I take a step down. Or we could say we're moving the decimal spot to the right for each step. Now, if we're doing the reverse, going from a very small unit to a larger unit, we're going to be dividing by 10 for each step that we take. Or we could say we're going to move the decimal to the left for each step. Now, here are two examples. We're converting 50,000 milliliters to liters. Milliliters is here. This is a small unit, and we're going to liters, which is the unit without a suffix. Since I'm going up, I need to divide 10 for each step, or I'm going to move the decimal to the left for each step. Okay, so 50,000. I have a decimal afterwards. I'm going to move the decimal to the left for each step. So milli to liters, I'm taking one step, two steps, three steps. So my decimal is going to move one, move two, and finally move three steps. That means that 50,000 milliliters is equivalent to 50 liters. Now, let's say we are trying to convert 13 kilometers to centimeters. Kilometers is up here and centi is down here. We're taking steps down. 1, 2, 3, 4, 5. I'm going to be taking 13 and multiplying it by 10 5 times, or I'm moving the decimal 5 steps to the right. Now, 13, I can have as many decimals as I want after the number. It doesn't change the number at all. Okay, so we're moving 1, 2, 3, 4, 5. The new decimal will land there, meaning 13 kilometers is the same as saying 1,300,000 centimeters. If you have the chance, pause the video, go to this YouTube link, and watch a reading of this book, 100 billion trillion stars. Excellent book about very large numbers. Now, when we're naming very large and very small numbers, we have these prefixes that help us, but after a while, even the prefixes aren't super familiar. So, one way that we can represent numbers that are really, really big or really, really small is a method called scientific notation. Now, inside scientific notation, we have a number that's significant to us, usually one digit in the ones unit, and then a decimal with several numbers times 10 to some sort of power. Now, for a very large number, we're going to have a positive exponent. So in this case, I have 376 million meters. That's the distance from the Earth to the surface of the moon. I could rewrite this as 3.76 times 10 to the 8. On the other hand, I can also use this to write a very small number. The smallest identified virus is the potato spindle tuber virus. It has a diameter that's less than 0.0000002 centimeters. Now, I could also say that as 2.0 times 10 to the negative 6. The advantages of using scientific notation would mean there's less room for error because we're not writing all of the zeros and possibly miscounting. Now, how do we write scientific notation? The goal for us is to determine the value of the exponent. But to achieve this goal, all we really have to do is count. So we're going to locate the decimal, and then we have to move the decimal left or right. The decimal needs to end up after the first digit. Then we're going to count the number of steps we moved, and we're going to rewrite the notation. Okay, the surface area of all the water on Earth is estimated to be 140 million square miles. This is a very large number. So we know that we're going to have a power with a positive exponent to it. So the number 140 million our decimal is here. I'm going to move it to here so that we have only one digit at the beginning. 1, 2, 3, 4, 5, 6, 7, 8. I've moved it 8 spots to the left. Now this is equivalent of saying 1.4 times 10 to the power of 8. Another example. The weight of a carbon atom is about 0.000000000000000001992 grams. Now, the fact that I've had to say all those zeros made my head hurt, and also I wasn't even sure how many zeros there were. So having a number like this is not super significant. But instead, let's count the number of zeros there are, and we're going to move it so that we have 1.9942 times 10 to the negative something. So here's our first group of 3, 6, 9, 12, 15, 18, 21, 22, 23. We had to move the decimal 23 spots to the right in order for us to make this number 1.994. Now we have 1.9942 times 10 to the negative 23. Great, here are a few practice problems. Please pause the video, go through this to find the correct writing for each of these large um, numbers. Now, how do you use your calculator to do scientific notation? Well, you can always type it in as some number times 10 to the nth power, but it's a lot of work and there's more keystrokes. The more keystrokes, the more potential for error. Now, the calculator understands 10 to the power n through the exponent button, exp. If you're using a school calculator, you're going to see something like this. So, for example, 1 times 10 to the negative 2. This is 0.01. We can rewrite this as scientific notation 1 times 10 to the negative 2, or when typed in, we would have one exponent button, exp, negative 2. Now, I want you to try doing these in your calculator. You're going to type in 8e, so E is the exponent button, 6 times 7e5. And you should get 5.6 e to the 12. I'll give you a little bit of time. Please type in these in your calculator to see if you can get the same answer. Here are the answers for these practice problems. Please pause the video again, and you are going to try these practice problems on your own. The answers are here. I've written it both in the scientific notation way that you would normally write it, and I have also answered it in the way that you might see it on your calculator.